This is the Generative AI Taskforce at the TUM Think Tank, bringing together a diverse team of experts and researchers who provide guidance to decision makers in government, industry, and civil society on issues related to the design, governance, and use of generative AI technologies. Today we're speaking with Daniel Rückert from the TUM School of Medicine and Healthcare and the School of Computation, Information and Technology. His research focuses on artificial intelligence and machine learning and their application to medicine and healthcare. So you mentioned that generative AI as a term as we use it is not really used that much in your field. Can you touch on that, how you define these different terms that are floating around?
Yes, I think generative AI is quite often used in the public press to describe a whole class of AI techniques. And I think many of us, when we use these AI techniques, we think of something called foundational models. So these are models which have been trained on a very large data set of often multimodal data, for example, images, text, audio signals, and other types of signals. And these models are then built to really serve as a foundation for multiple different tasks. So we quite often call these models foundational models, but you might also call them, for example, large language models, where they quite often sort of then use text as input and as output. So these are sort of very common terminologies we use in our field.
Okay, got it. So I should not be saying generative AI, but rather...
I think generative AI is fine, but I think often people think of generative AI as something which, for example, generates an image completely artificially. But for us, for example, in the medical field, we're quite often interested in interpreting text and, for example, generating an answer as text. So the generation really is often done in terms of language, and therefore the term large language model.
Okay, got it. So where do you see the greatest potential or use cases of these large language models in your field?
So I think one of the things we've seen in the last couple of years is that AI has been very good at answering a single question. For example, you might in the medical field ask whether a patient has a certain disease or not. And the AI would give you an answer. And with that answer, you can then make a decision on, for example, how to treat that patient. But you couldn't really interact with the AI. Now that we have these large language models, and for example, ChatGPT is perhaps the best known large language model, you can interact with the AI. So you can, for example, ask the AI, has a patient a certain disease? You get an answer, not only yes or no, but actually in terms of text. But also you can then query the AI and ask the AI, tell me, why do you think that patient has this disease? Or what should I do next as a next test? So we can now interact with AI, something which we couldn't do beforehand. And I think, for example, in the medical field, this has huge impact because traditionally, when you go to the doctor, you have a conversation, the doctor asks you questions, you respond, and based on that, over time, the clinician will form his or her decision on what the likely diagnosis is. But it's not, I would call it a single-shot diagnosis where you have suddenly all the information and that's it, but it's an interaction. And I think that's an incredibly powerful tool which we hadn't had before, which I think will transform clinical practice, for example, with AI.
Yeah, oh, I see that. If you can then just ask back and forth and use it as a sparring partner, right?
Exactly.
Yeah. But regarding that and thinking about the hallucination it still does at this stage, which let's see where that will go and if that can be tuned out. But what are the most prominent challenges then in your field regarding these large language models? Is it that they hallucinate a lot still, or?
So I think in our field, probably hallucination is a problem and it occurs, but it actually doesn't often occur in very prescribed settings. I think hallucination often happens when you ask very open-ended questions. For example, if you ask ChatGPT, write me an essay on a certain topic, and then you ask it, give me some references for this. Most likely these references are made-up references. They don't exist, correct? They're hallucinated. But I think if you ask it typically very specific questions, you also get very specific answers. And I think they're most likely not hallucinated. But I think one of the major challenges we have is that it's not often easy to spot these hallucinations. And that's where we need to use a lot of expertise, human expertise, to judge whether this makes sense or doesn't make sense. I think that's one of the very significant challenges we're facing. But I think there are also a lot of other challenges we're facing. For example, quite often we don't quite know what the system knows and what it doesn't know. It's related a bit to hallucination, but for example, a lot of these ChatGPT versions which exist in the medical field have been trained on all of the medical literature which is around there. Now there's in certain areas a lot of literature, and in other areas there's very little literature. And so it's very likely that these systems know one part of the medical physiology and medical literature very well, and others they don't know very well because there's just much less data in this field. And so this then leads to the problem that we don't quite know where can we rely on the system, what might it, for example, be able to spot, and what might it not be able to spot. And that's, for example, a problem if you quite often leads to potentially errors in domains where you have very rare diseases, for example. Or it could potentially also lead to errors where you have underrepresented patient groups, for example. If you look at PubMed, which is a medical body of literature which exists, mostly comes or is generated in the Western world, so North America, Europe, and it, as a result, therefore describes predominantly disease characteristics in that population and probably doesn't cover other parts of the population. And these biases which exist in the data are then also transferred into these models. And I think that's another big challenge for us.
The reinforcement of these biases.
Exactly. But I think it's important to realize that these biases exist already, and they are not introduced through the AI, because whatever we teach our medical students is in some sense the same thing. But it is a problem because we're probably, as you said, reinforcing or amplifying these biases.
Because it is then just a mirror of the world that it learned from, right?
Exactly. And sometimes you don't even know what it has learned. So the biases become perhaps less obvious, correct? If you read at the moment a medical paper, it typically will tell you our study population is a population from this cohort. And perhaps that's not representative. But once you have put it in the AI, that disappears and you're probably no longer really aware of this.
Got it. And so I think that's an interesting point. And also the societal debate talks a lot about what can we do to unlearn these biases, or that we create now like systems that have already unlearned them, or try to prompt them in a way so that they can be less biased. And I think it's a great thing that we're talking about it and that we're trying to solve that. But is there any other points that you're missing from the wider public debate right now? Is there any blind spots that we should be maybe talking about that we don't know yet?
And there are certainly some blind spots, but I think there's also in the public debate, I think a lot of focus at the moment on the dangers of this technology, and perhaps too little focus on the benefits of the technology and, for example, how it might empower both patients but also clinicians much more. I think, for example, this technology has a potential to help, for example, communication between clinicians and patients. It might really automate a lot of the paperwork, for example, clinicians do, and that means they have more time to talk to the patients. There are also studies which have shown that actually a chatbot like ChatGPT probably has more empathy with patients than clinicians show when they talk to patients.
Interesting, because usually you would say, the thing that it can't do is empathy or feelings. And it's interesting that you now say in some cases they have more.
Yes, I think the perception by the user, by the patient, is that they have more, correct? I mean, and I can understand this. Probably quite often you go to a clinician, they have a very busy schedule, correct? They tell you this is a situation, and then they want to see the next patient, correct? And you as a patient, you might say, well, I have some questions, or for example, what the clinician has just told you might come to you as a shock. And you probably would like to discuss this with somebody, ideally the clinician, but perhaps they're too busy to really do this. So I think quite often we think that the current status quo is ideal without really realizing, I think there are many shortcomings in our healthcare system because of resource implications, correct? And I think this type of technology, while it has its dangers, offers also a huge amount of potential to address some of these resource implications.
Yeah. And that actually sounds amazing. If you do the paperwork, even helping patient, or as we talked about earlier, about the sparring partner already.
And exactly, I think if you think about this, we in computer science, we defined, or many years ago, Alan Turing proposed something called the Turing test to test whether a system is human-like or has human-like AI capabilities. And that simply involved a human communicating with somebody else behind the screen without knowing whether they talk to a computer or to a human. And you would say you have passed the Turing test if the human can no longer detect those differences. Now, not detecting these differences has all sorts of implications, but also has benefits. Because, for example, if the patient really has a benefit talking to somebody, and for them, actually, the responses are completely human-like, then they can talk to somebody about their problems, about perhaps their feelings and also anxieties they might have. And it really serves for that patient the purpose it's designed for, correct? And I think we need to sort of monitor this closely, but I think there's a huge potential also in really empowering patients and, for example, asking a patient much more interactions with a clinical expert, whether that expert is human or automated. You might, for example, ask your expert clinician every day, based on your latest symptoms and feelings, what should you do, what should you not do? This is something which would not be possible in our healthcare system because we wouldn't have the resources to do this.
Exactly. So you could monitor patients much more closely.
Exactly. And give them also much more guidance. I think quite often what happens in the medical field is you get a therapy plan from the clinicians, and then patients don't quite stick to that therapy plan because they don't understand it, because there's some circumstances which allow them not to really stick to them. And if you could interact with the AI and ask, so I haven't been able to take the medication this morning, what should I do now? And the AI might tell you, well, take it now or just leave it until tomorrow and then take it again. But make a note of that in, for example, in your future prediction, how your disease will develop, because you've taken a gap in your therapy, for example.
I think oftentimes we just tend to focus on the dangers and the threats, and obviously they're out there, but listening to that story now and how it could actually improve a system that is to some degree flawed and we know it, that's amazing. And when we think about that, these systems or these models haven't been known for such a long time, at least, but in the broader public, it's been around for like the last year or so. So where do you see this going within the next year? What do you think is next when it comes to these large language models?
I think they will, I suspect they will improve quite a bit, but then also hit a sort of ceiling of how much you can improve them. I think in the community, in the AI community, there's a lot of debate on whether these large language models can ever completely mimic human intelligence, and perhaps they can't. But I think nevertheless, they can probably be more powerful than human intelligence. So I think we'll continue improving them over the next years. I think one of the challenges I see in this field is that in the past, a lot of the research has been done in the open and also in academia and industry. And now that there's a lot of commercial impact of this, some of the big companies, OpenAI, but also Google and Facebook, have stopped being quite as open as they have been in the past about the technology development. So if you look at some technologies like the latest version of ChatGPT, there's actually no scientific literature which describes exactly how it was built and how it was trained. So now you have systems which are effectively commercial products, and you don't 100% understand how they work. Or I would say we understand the principles on which they're built, but not exactly how they It's a bit like you're buying a car and you cannot look at the motor, and you know it's a sort of diesel engine and it will work like a diesel engine, but you don't know exactly the details of how it will work. That's a bit the situation we're currently in. And I don't think that's a particularly healthy situation, because I think we need more openness also to overcome some of the I think the fears and the challenges we're facing in this area. And I think that's best done through openness and transparency. And we also, I think governments have to think quite carefully about how much of that they're willing to allow to be done by private companies, and how much of that should be done for the benefit of the public in general. But also, I think there's a lot of competition between different nations, I think, in this space as well, which means it's very hard to regulate this space, because I think everybody is sort of worried that they regulate too much, and therefore stifle innovation and companies. And some of the big companies, obviously, they can develop in Europe, in the US, in other places, wherever it's easiest for them.
True. That is true. And then maybe one last question. You've touched upon the medical scene now, but how do you yourself use generative AI or even ChatGPT right now?
I think I use it for not very intelligent tasks. I quite often use it if I need to rephrase something, some text we have written, or if you would like, for example, you're writing something for a paper and you, for example, need some bullet points, how to structure and organize, for example, some text. It's very useful. And I find that in my work, I quite often use ChatGPT to translate English text into German text.
It does quite
and it does quite a good job. Actually, it does a better job than I would probably most of the time do. So I think that's pretty mundane tasks. And I think that's where it also excels, because if you write an email and then reformulate it, it's not actually absolutely critical whether ChatGPT gets it right, correct? You have a body of text, you can edit it, and that's it. So it's not mission critical. But I think a lot of the applications which are proposed as well are more mission critical, whether it's in healthcare or in other domains. So that matters much more whether you're generating the right output or not.
Definitely. And then let's see how that develops. Thank you so much for this great talk and for coming here.
Thank you very much. It was a pleasure to talk to you.
Thank you for listening. If you have questions, challenges, or use cases that you want to bring to the task force, write us at TUM Think Tank at hfp.tum.de.